Molarity. All right, so more about the mole. All right. So we're going to talk about basically a solution is just dissolving one thing in another. Okay? Like this solution right here. What is this? Sodium chloride salt in water. Okay? There's salt crystal dissolved in the water. There's excess here because we've maximized the amount of salt that can be divided, that can be dissolved in here. All right, so this stuff will never go into solution. If you can't dissolve anything more, we'll learn this later on. This is called a saturated solution. But basically, this unit's all about dissolving something else. So some terminology, because there's always terminology in chemistry. The solvent is the most abundant component of the solution. It's what does the dissolving, if you want to think of it that way, is the most abundant. So in this solution of sodium chloride, salt in water, the solvent would be the water because there's more water than there is of the salt. The solute is the less abundant. It's the thing being dissolved. What does aqueous mean? It means you have dissolved it in water. The solvent is dissolved in water. Okay? Where the solvent is water, H2O. All right. So if you have salt water, we just talked about this. This is salt water essentially. All right. What's the solvent? It's either the salt or the water. What is it? It's the water, the more abundant thing. So the solvent is the water. The solute is the salt, NaCl. In Kool-Aid. If you make Kool-Aid, I don't know if you make Kool-Aid. Do we still eat Kool-Aid? Drink Kool-Aid? Because you don't eat Kool-Aid. Drink it. Yeah, I eat the crystals just every morning for breakfast. With what? That explains a lot. And Kool-Aid, what's the solvent? What do you dissolve it in? Water. And the solute is basically sugar. Colored sugar is basically what Kool-Aid is. If you want a visual representation, solute, a few particles. The solvent is the more particles. When you mix them together, we're going to learn this later on. And in grade 12, and if you go on in chemistry, you learn more about the interactions and why it dissolves. We'll touch on that in this class. You mix them together, you get a solution. Okay? And you can see that the solvent is dominating the solution in terms of there is more of them. All right. AQ. So when we write things, we can write H2 and I write a G. What does the G mean? Gas. If I say water and I put an L there, that's an L. What does the L stand for? Liquid, right? If you write, just to be complete, if I write NaS, what does the S stand for? Solid. If you write AQ, what does that mean? It means aqueous. It is dissolved, you're right. So it means aqueous, which means you're dissolved in water. Water is the solvent. So we would just say NaCl, sodium chloride, which is table salt, AQ, which means sodium chloride, table salt, dissolved in water. As soon as you see AQ, you know the solvent is water. It doesn't always have to be liquids and solids, though. Okay, for a solution. That's a common one that we see a lot. So liquid, solid, We've just done it. Salt water. Sorry? Oh, is it?
It's bothering me.
Let me turn it off.
Turn it up. Yeah. Yes, please.
All right. There. It's gone? Okay, I just turned the speaker off, basically. All right. You can have gases dissolved in each other. Like basically it's a mixture of gases. Well, it's a common mixture of gases. There's one in this room right now.
Oxygen and
Exhaust. Yeah, that's a mixture of gases. That's right. But the air in this room is a mixture of gases. Okay. What are the mixtures?
Yeah. Is there oxygen?
Well, I'd hope so. Otherwise, we're in trouble. There's oxygen, nitrogen. There's going to be, I think there's argon. I can't remember. I'll look up the actual percentage mixture. I don't memorize all this stuff.
Oh, you should just know.
Okay.
Yeah, shouldn't you know that?
Shouldn't you know that?
Didn't you know that?
All right. You can have liquid mixtures. So if you mix liquids, I don't know, water and vinegar. You can dissolve gases into liquids. So a liquid gas mixture. What's a common one of those? Sorry? Pubs? Pepsi, pop. Yeah. Pop is gas dissolved in liquid. Right? So pop. That's why it bubbles. If you shake it up and then you open it up and it goes everywhere, that's the gas, carbon dioxide. Carbon. Yeah. Solid, a sandwich. Could be a sandwich. We're going to do a metal alloy though, but a sandwich is a good example. Metal alloy is like, remember when we made the pennies? We coated them in, what did we coat them in? Copper? Zinc? And we made a copper zinc alloy. You mix metals together. So steel, steel's sort of, it's carbon and iron. The alloy, it would be a new compound, right? If you wrap something in tinfoil, you're just kind of covering it. I get your. It's an okay visual, but it's not tact. If you integrated the meat into the bread, that would be an alloy. That's more along the lines. You really want the food theme here. If the bread, wow, I can't believe we're going down this road, but whatever. But it's still like a hole, right? With the what do you call it? The cheese, right? Yeah, but if you had the bread with the cheese like weaved throughout the whole thing, it was like one substance. Yes, that would be like an alloy. A cow's really leaning hard into the food analogy, aren't you? Okay, we'll go with that. Okay. The point is, it doesn't have to be solid liquid. Okay. All right. Molarity. So we have to have a way to measure how much of a substance, this is usually going to be liquid solid, is in the liquid. All right. So we call this concentration. It's the amount of solute in a given volume of solution. So it's how much stuff is dissolved. That's essentially what we're talking about here. Now these are general terms, what I'm going to say right now. So if there's a lot dissolved like this, all right, we call that concentrated. And if there's only a little bit dissolved, we call it dilute. So a visual is the dilute does not have very many particles. The concentrated has a lot of particles. That's really all they mean. They don't represent numbers. There's no definitive point where it changes from dilute to concentrated. All right, it's just sort of a general term. We're going to look at the numbers in a sec here, though. So the amount of solute, what you're dissolving, is usually measured in grams or moles, which are interchangeable. We're going to use moles a lot. And the volume is usually measured in liters or milliliters. Milliliters or liters. So when you're talking about concentration, the units can be grams per mil, grams per liter, moles per mil, or moles per liter. This last one is the one we're going to focus on. So most things, if you remember when we did the lab last Friday, we used the acid, or whichever one we used the acid, and I said it was like 6 molar acid, which is a high concentration. That would be a concentrated acid. Molar is moles per liter. This is the common one that we use. All right. So and it has a term. So can't write in moles per liter, and that is called molarity. All right. So I would say the molarity of the solution is 6. All right. And that tells you it's 6 moles per liter. All right. So what does this mean? Molarity or molar, they call it molar too. It's the number of moles of the solute dissolved in 1 liter of solution. So in other words, molarity is moles per liter which you'll probably usually see like this, mole over L. And then sometimes you see it like this, which I don't love this formula. N is equal to, or C is equal to N over V. N is number of moles, V is the volume, and this is the concentration. I will just use moles per liter, MOL over L. That's what I'll use a lot. Because that's what most things are. All right. So instead of writing the word molarity, chemists don't like doing that, so they shorten it. Okay, just like moles, we just drop the E, right? MOL, because we're lazy. All right. So instead of writing molarity all the time, all right, we use a capital M. It must be a capital M, not a lowercase m. Okay. And then we pronounce concentration as molar, right? Or the molarity. So if you were talking to somebody that was a chemist or whatever, they wouldn't say 2.1 moles per liter. If it was written on the bottle, it would be written as, why is my pen not working? There we go. 2.1 molar, 2.1 capital M. And we should just write that as, let's just change it to 2.0 because it's just easier. So just scratch out this 0.1. 2 moles per liter would be written as 2 capital M, 2 molar, and you would say 2 molar. That's what somebody would say. Say, what is the concentration of that? You'd say it's 2 molar, which means 2 moles per liter. Also, because we're lazy and we don't want to write concentration, we have a special notation, which are these square brackets around the substance. So if you put square brackets around a substance in chemistry, that means the concentration of that substance is, and then whatever the number is. So we use square brackets to represent concentration. Like that. Not round brackets, they have to be square brackets. Okay? So this here means the concentration of sodium chloride is 1.2 molar. All right, are we okay? That's sort of the background theory. Now there's a bunch of calculations. You got to know how to do it. Okay? Here we go. So remember, capital M, this is your formula, is moles per liter. That is, you'll get that. I'll write it on the board, but this is what we're going to use. And we're going to manipulate this. So, all right. A 2-liter solution contains 5 moles of NaCl. What is the molarity of NaCl? All right. So we would say, first thing I do is I write out the formula. Capital M is moles per liter. All right. How many liters do we have? 2. So I put in, for liters, I write 2.0 liters. How many moles do we have? 5. So if you divide those, what's 5 divided by 2? 2.5. How many sig figs does our answer have to be? 2 sig figs. So it's 2.5 what? Moles per liter, which is 2.5 molar. So then if somebody asked you what's the concentration, you would say the concentration of NaCl, square brackets around NaCl means concentration, is 2.5 molar. All right. Are we okay? Okay. 10 grams of potassium chloride, KCl, is put into a 250 ml volumetric flask. What is the concentration? Remember that concentration is molarity, capital M. Right? So they're saying, what is capital M? You only have one formula. You have that formula. Do I have liters? Where can I find liters? Yeah, like you have 250 mils. How many liters is that? 0.25. That's 0.25 liters. I guess I should write it with correct sig figs, because this has 4 sig figs, so it's 0.2500 liters. So you divide by 1,000. There's 1,000 mils in a liter. Okay. So I know this number. I know how many liters we have. I don't know moles. How can I find moles? Sorry? Yes. So you're going to use the 10 grams. I got to convert the grams to moles. So what do we need to do that? This is the last unit. molar mass. So you have this pen. I don't know what the molar mass of this compound is. Sorry, what is it? 74.6. So we're going to go 10 grams of KCl. 1 mole is 74.6 grams, which gives me 0.134. Is that right? Moles of KCl. All right. So now I have enough information to calculate molarity. I have the moles and I have the liters. Remember, it always has to be in liters. So moles is 0.134. The liters is 0.2500 liters. And if you divide those, you're going to get 0.536. I don't know who said that, but molar. Is that okay? All right. What do the square brackets mean? Concentration. And remember, concentration is capital M, molar. So this says, what is the concentration of copper chloride solution that contains 7.48 grams of copper chloride in a 500 ml flask filled with water? Okay. So, do I like my answers do I like my volume in liters or in milliliters? You want liters. So 500 mils is how many liters? 0.5. So this is 0.50000 liters. Do we like grams? No. Grams are good for when you're measuring stuff out, but what we want when we're calculating concentration is moles per liter, right? This is our formula. So I have to convert 7.48 grams of copper chloride into moles. So you need the molar mass. Uh, 134.5. That's what I have written down. So 7.48 grams, 1 mole's 134.5. So if you divide those, you're going to get 0.556 moles of copper chloride. All right, what do we do now? You just put it in the formula. Number of moles divided by the liters, which is and that spits out 0.111. 0.111 molar. All right, a couple more examples. What is the mass of sodium hydroxide, NaOH, contained in 3.5 liters of 0.2 molar NaOH? Okay. We want mass. Mass is measured in what units? Grams. Okay. So I want to know grams of NaOH. We know that we have 3.5 liters, and now we know the concentration, right? So the only formula we have right now is molarity is moles per liter. Do I know capital M? It's 0.2. Do I know moles? You don't. But I do know liters is 3.5 liters. How can you calculate the moles? This is just a math problem now. You're going to multiply the 3.5 up here. That's going to give 0.700 moles of NaOH. Did I want my answer in moles? You want it in grams. So now I got to convert the moles into grams. Using what? Molar mass. This is why we did all the molar mass stuff. So 0.700 moles of NaOH. NaOH is 40 grams per mole. Those cancel. If you multiply it out, you get 28.0 grams. So this is a common question because what it looks like if you're in the chemical storage room is you're like, I need to make 3.5 liters of 0.2 molar for something. So obviously then you got to calculate, well, how much NaOH do I need? I need to put 28 grams of NaOH in that 3.5 liters. Okay. So the 28 grams is what you can actually weigh out. All right, last one. That is. Do you have another question?
No.
Oh, okay. Let's do actually. Come back to that. If you go to. No, I think that's good. Go to this page. You have this page. It's like 2 pages forward, I think. I'm going to get you to work through those questions. Look, for number one, like ideally you do them all, but these are all kind of the same questions. So let's do A, C, and E for number one. For number two, we'll do A, C, and D. And then you should do the rest on that page. And I'll post the key. I'll give you some time to work through that. Does anybody have any other reviews? A bunch of people handed me reviews. Does anybody else have reviews that they need to give me? Okay, that's fine.